Okay. If a microstructure development during the continuous cooling, so the final microstructure of the steel depends on the cooling rate and the temperature at which the transformation occurs. The final microstructure of a steel depends on the cooling rate and the temperature at which the transformation occurs. So at what rate that we are allowing them to cool, it depends. It basically decides the microstructure of a steel. Okay, and at what temperature? I mean the cooling rate, and at what temperature it is being transforms. So transformation occurs at what temperature that decide the microstructure of steel, and that microstructure will decide the mechanical properties of steel. Okay, so following microstructure can be developed during the continuous cooling. Here you can say the same thing, the Pearlite, okay, Bainite, the same case is just repeating, okay, Martensite. Okay, we are having the same again, so we are not going in detail again. And here the just one thing extra, which is a mixed microstructure. Here what we are getting, formation occurs at the intermediate cooling rate where partial transformation to the Pearlite, Bainite or Martensite occurs. So it is a mixed microstructures. Properties, a combination of a hardness or strength and toughness depending on the properties of each phase. Wherever you see it is at a very high temperature, then all the properties would be having the ductility kind of things. Okay, the high ductile, high hardness, high strength. Okay, low hardness. If they are having a very low temperature, then low ductility, high brittleness, high hardness. Okay, so these are the just opposites. If anything which comes in between these two, then you just have to say all about the moderate things. They are not good, not bad, but in between that.